Okay, let's take a look at um, this. This is similar to what we did. Now, you can also do a try and error method, and see which of them makes sense. The sum of the digits of two-digit number is 7. When the digits are reversed, the number is increased by 27. Find the digit. So here, like I said earlier on, you want to do a try and error method. So when you have the sum of the digits to be, you can start with 0 and 7. So 0 and 7, uh, uh, when you sum them, you get 7. When the digits are reversed, that is increased by. So that means when you reverse, it becomes 70. Then 70 minus 7 is supposed to be equal to 27, but that is not true. So it cannot be. So let's try another one, which is 1 and 6. Let's say 1 and 6, and then 61 minus 16 is supposed to be equal to 27, but we know that is also not true. Or this actually equal to 45, right? 61 minus 45, so that is not true either. So let's move on to the second one, which is 2 and then 5. Give 7, and then the cousin of that is 52 minus 25. I think this gives you 27, so your answer is 52. So the original number here is 25, right? So that is what the original number is. The original number is 25. So try and error is easy. If you play this in, it's about maybe a couple seconds, you get your answer. Now, how about if you want to do the algebraic one? We can do the same approach. So we are saying that the original number is, x and then y, and when you add the two together, x plus 1 is going to be 7. When you reverse the number, then the new number, which be equal to 10 times y plus x, when you subtract that from the original number, which will be 10x plus y, that should be equal to 27. That is how you should form this equation, right? So now if you simplify this becomes 10y plus x minus 10x minus y is equal to 27. Let's simplify this. So 10y minus y give me 9y, and then I have minus 9x is equal to 27. So that gives me y minus x is equal to 3. So when I add, let me see, I can actually change this, and this equation becomes y plus x is equal to 7, the first equation. So when I add the two together, I get 2y is equal to 10, and therefore y is equal to 5. If y is equal to 5, then obviously my x is equal to 2. So the original number is 25, right? So I can do that. See, so you can also solve it that way, and that's also straightforward. But this is more difficult. This is more complicated. This is more. You got to think a little more than for this. But the try and error method is good, and for the SAT and other tests like the ACT, you want to look into this approach, the first one approach, and makes life very easy and simple.